digital circuit design optimization. Some people like to ask this kind of questions. So question is, we have a given circuit. Now, how do you want to optimize it? So let's start. Oh, if you have seen this circuit, just don't tell, hey, A or B is F. That's no. They want to see a process of how you solve question. So okay, so I'll label A, C. So we want to show race condition, and it's better to show how race condition is made. So yeah, so let's make race condition. Assume B is 1. So when B equals to 1, this AND gate, it's gonna be just wire to C, or you can assume a buffer. Reason is I'm just filling out AND gate. As you can see, C equals to A bar. When C is 0, A bar is 0. When C is 1, A bar is 1. So it's pretty much propagation. Now, let's redraw a circuit. Now in here, we want to show how race condition is made. So let's make a waveform. Let's say A is at 1. So A bar is at 0. And F is 1. Now you see, in this timing, A goes to 0. And you see A bar is 0, which is here. And it changed from 1 to 0. So, so this 0 is new input. We should be getting 1 here, right? And let's assume in order to get this output, it takes, let's call it t. It takes time t. So we can say this window is t. It takes delay of t to be high. Now if you look at output, we have 1 and 0 here, so it's 1, right? Now we're having 0 and 0, so it would look like something like this. Now you see A bar is going high, and you see the sky will go up. And if you write it in a Boolean expression, A plus A bar, it's 1. So F should be always 1. But you see a glitch here. And when glitch happens, it consumes some power. And in VLSI, we want to save power. That's why glitch is bad. So, next, we want to tell how can we get rid of it. Because this is not good design. And you may think, okay, how about I just fill out table A, B, and F, and you just look at each wire's value, then you get new logic. I don't recommend doing it. Reason is I'll show it later. What you want to do is, let's say, hey, you have C. What is C, right? So C equals to A bar times B. Now you see, what is F? F equals to A plus C, which is A plus A bar times B. Now you want to reduce logic. How can you clean logic? So if we want to reduce logic, we want to reduce this guy. And we need to make some new dependencies. So I would modify A to be A equal A plus A V. You know, it's still A. I can show you why. A is 1 plus B, and this is always 1, and A times 1 is A. So we can make this logic, and we're gonna substitute and get A plus AV plus A bar V. Okay, so we are here. Now we can actually reduce this logic here. So we have A plus B times A plus A bar. You know, A plus A bar equals to 1. We have seen the example here. It's always 1. Now we get A plus B times 1 is B, so we get A plus B. That's how we solve this question. Okay, let's go back why I said you don't want to give a table. Because let's say I'm interviewing you, I will say, hey, wait, I actually changed my mind. I want to add a new signal called C here and make OR gate, and D and make OR gate. Now, can you solve this question? Oh, excuse me. Now, as you can see, if I added more gates, you cannot really use tables. I mean, you can, but it's going to take so much time. So interviewer's intention is to not let you use table. So you have to use a Boolean expression to reduce logics. And you'll still get A plus A bar B plus C plus D. I hope you understood how this circuit was optimized. If you have any requests to be covered by me, please let me know. And the next video, probably I'm gonna give some different interview questions so you can get some practice. Thank you.